Okay, so we're doing finishing this. This is the calculator part. Okay, so let's see. This is a good question right here. This question is one that we're going to practice. I call it graph given. Let's call it GG for graph given. There's some free response questions like this sometimes too. Okay, this is a graph of f prime, the derivative of a function. Okay, so f is not shown. The domain of f is the open interval 0 to d. Okay, which the following statements is true. So we want a local min, local max, point of inflection, concave up. Okay, so local min, local max, that's going to be f prime. So we need to do an f prime number line. So we're going to go from 0 to d. Okay, now f prime is what the graph is labeled. So it's the y value of the graph given. Okay, and that's because they say the same thing. Okay, so labeled the same as this. So that's above and below. So above and below. So it's below until where? So I would say A. Then it's above until where? C. And at C and A, there's 0. And from C to D, below. And this is going to be for both A and B. Local min, local max. Okay, so let's see. Decreasing. F is decreasing. F is increasing. And F is decreasing. So looks like it does have a local min, it does have a local max. Okay, local max is at x equals b. No, wrong spot. Local min at x equals c. No, that's a max. Okay, so no. Interesting though. Okay, true. I am looking for true. Okay, C, D, and E are point of inflection, concave up. So that would need a second derivative number line. Now, if you have f and you're trying to get to f double prime, so from f prime to f double prime, how many derivatives do you need? I would say we need one derivative. Okay, and one derivative. So over here on the right side of my number line, I'm going to put slope of f prime. Slope of f prime. Okay, so the slope of f prime is, so I am ignoring for the moment the f double prime. So I'm ignoring that, and I'm just focusing on the right. So the slope of f prime. So from 0 at the beginning, it's increasing until b. B, the slope is 0. Remember, we're looking for the slope of the graph given. Okay, the graph given is f prime, not f. It's not f double prime. Okay, so slope is positive, then it's 0, then it's negative because it's decreasing. Okay, and then on the f graph, which is not shown, that's concave up and that's concave down. So let's see, point of inflection at b, f of b. I like this one. Point of inflection at A, no. And it says it's concave up in the open interval from C to D. Where is C? C to D? No, C to D, it's concave down. So that'd be a no. So then D is the answer. That was kind of fun. Okay, so basically what we're doing is with graph given problems, I like to have multiple labels. One label is what I'm actually looking at on the graph, and then the other label is its real name. Okay, so let's see. 77. Water is pumped out of a lake at that rate. Cubic meters per minute. Okay. Where T is measured in minutes. How much water is pumped? Okay, so I like to have a chart for accumulation functions. We don't really need one for this, but it's a good time for us to discuss it. This is the rate. Okay, I usually don't call it R of T though, so let me just write the word rate. Okay, so this is the rate, and this is the amount. Okay, so, and then what I like to do on those word problems is I have a start. There's no start rate, but there's a start amount, and sometimes I say where it starts. And then there's in, there's out, and then there's total. In this one, it's saying how much water is pumped out of a lake. Okay, so my out is R of t, and they didn't give me any of the other values. And they want how much water is pumped, and then amount is the integral of rate, and rate is the derivative of amount. So that's how it works. Okay, so basically I have to take the integral of the rate from 0 to 5 in this case to find out the answer. I could do this by hand, but we are not going to do this by hand. Okay, so this is 12 t over t plus 1 dt. Okay, so let me see if I can do this. I'm going to take a picture with my phone, and then I can type it into the calculator. I found that on my tablet, I can do left and right screens. So that's pretty awesome. However, when I do the graphing calculator, the buttons aren't in the right spot. So it doesn't work. So let's see. I'm going to go out here. I'm going to go, this is my new tablet. Oh, look, I was playing Minesweeper. Calculator's right there. Okay. So let's see. I don't know if this, it looks like this automatically switches the direction as well, like on the other one. Okay, let me look at my picture. Okay, so my picture says I need to do Math 9, 0 to 5. This, I usually would put Y1, because I don't like to deal with the parentheses. But we can try it here. So 12 square root, and then that's a fraction. So, oops. T divided by parentheses t plus 1. Okay, I'm using x's. That's all underneath the square root. So I think we're good. I'm doing dx. X over, make sure you type it in right. $49. Let me write this on my phone too. Okay, maybe I'll write it on my paper. Okay, so that's 47.193. So I'm going to go back to my other screen. Okay, so back to my other screen. Where was I on my other screen? Let's see. I was in this one. Okay, let me twist it. There we go. Okay, so this is 40, let's see where we were. We were right here. 47.193. Oops, I keep hitting my button on my new tablet pen. I was using my phone tablet pen before. Okay. So if you have your in and your out, you subtract. Total, you can total your rates. You can do in minus out for your rate, and then that's the derivative if you need to graph the derivative. So we'll do a free response question where we kind of use that same chart. Okay. 78. Okay, this is a graph given problem. I don't know, it looks like it might be a limit though. Oh, okay, it is a limit, so I wouldn't call this a graph given problem. Okay, the graph of a function is shown above. For which of the following does C have the limit? I need the limit to be 1. Okay, I can look at all these different spots. 0, 3, negative 2. Oh, there's only 3 spots. So let's look at their spots. So 0. If I'm looking here at x equals 0, both sides, right side, left side, are they both headed towards 1? They are. So the limit as x approaches 0 of f of x is 1. So that would be, which of the following C does this equal? So 0 is a possibility. So yes, 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 no, yes. Okay, that was not helpful. Okay, let's try 3. So limit as x approaches 3 of f of x. Let's look at the picture. So 3, the limit from the right, looks like it's about a half. And the limit from the left looks like it is 1. Okay, so I would say that's a does not exist. Okay, because the right and the left-hand limits have to be the same. Okay, and then if you needed a because, if you're doing a free response question, it's the limit as x approaches 3 from the right side is a half, but you would put but the limit as x approaches 3 from the left side is 1. So these two don't match. Okay, and that's actually step 2 of the continuity rules, which is there a limit? So I would say 3 is a no. So no, no. Okay, so I still have to check -2. Okay, so let me check -2. Limit as x approaches -2 of f of x. Okay, so -2 is over here. The right limit looks like it's 1. And the left limit looks like it's 1. So it is 1. Now, Mr. Knox is not home. So there's no Mr. Knox. Okay. He's not in his classroom. But you were just trying to meet up with your friend. So the limit portion is just, are you and your friend going to the same spot? Okay, so does your right hand and your left hand, do they meet as you're going towards the same spot? It doesn't matter if there's an open circle or even if there was a closed circle up here. That just means Mr. Knox is somewhere else. But there's still a limit. It's just not continuous. So we decided that was a limit. So -2 does have a limit. So it should be this one, -2 and 0. So this one's a yes. This one was a no. This one was a yes. Okay, let's see. 79, positive, continuous, decreasing. So positive means it's above the y-axis. Continuous, okay, no holes. No holes, no asymptotes, no gaps. Decreasing, okay, going down. Such that an is f of n, okay. Let's see. I still don't know how to pause on this thing. Okay, I'm not sick. I don't know, I'm sneezing. Okay, so if this converges, which the following must be true. Okay, so we have a convergent sequence. So it definitely converges. Okay. Okay, it's not alternating. I feel like this one has to do with the nth term test for divergence. There's a rule, and it might not be that, but there's a rule that says the limit as n approaches infinity of an if then does not equal 0, then this diverges. So if you wrote that backwards, that would say if you not it. So if this, and this actually I don't think is related because I'm looking at all the answers and they look like the integral test. But let's check. If the does not, so if it's not true that this diverges, then it's not true that the limit as n approaches infinity is not 0. So if you not these, this one would say if this converges, this is called the contrapositive from geometry, then what's not, it does not equal 0. Well, that means it equals 0. Okay, so that kind of looks like A, but this would have to be 0 and not K. So I would say that's a no. Okay. Diverges, converges. Okay. Looks like it's the integral test. So if the series converges to K, does the integral converge? I feel like that's the integral test. Except they're using f instead of a because it's an integral. So this would be f of x dx. And then from 1 to infinity. And if that converges, then this converges. Back and forth, integral test. I would say diverges would be a no. I would say B does not have an infinity. This one is no because of the diverges. Looking at D and E, it's D. Let me tell you why it's not E. Now this is an IB thing that we didn't really talk about. That's okay. But if you have an integral, you have an integral like this, you know what an integral is. You know the integral is this shaded part. But what's interesting is the series. Okay, I'll do it in red. The series is actually the rectangles, the Riemann sums. Okay, so the Riemann sums. So the height at 1, the height at 2, the height at 3, those are actually the summation. It's very cool. So each width is 1, and each height is like A1, A2, A3. So the series is actually the left endpoint Riemann sum. 1 times A1 plus 1 times A2 plus 1 times A3, etc. It's very interesting. You can also do it and then do the right endpoints instead. And then it just has kind of a different start. You would be starting at A2 instead of A1. But anyway, it's very cool. Or you can start at the, oops, I just changed that to A0 and that was supposed to be a 1. Not sure if that's come up on the AP test before. I can't imagine they're going to put a really tricky one this year all of a sudden. So we'll see. Okay, so that's D. That is an IB thing though. Okay, 20, page 20, 80. The derivative of a function is given by, okay, so they gave me the derivative. How many points of inflection does a graph have? Okay, this is a graph given problem. I know it doesn't look like a graph given problem, but you know, my graph can be given by my graphing calculator. I give myself a graph. I'm on the calculator section. I wish I had a graph. So if I wish I had a graph, I can make myself a graph. Or I could take the second derivative. Can I take the second derivative correctly? I feel like I could take the second derivative correctly. So let me take the second derivative. The second derivative is usually whatever you're trying to find. So this is points of inflection. It's a little bit easier if you have the actual function and not the first derivative if you want a second derivative number line. So I would rather have this if I can, but I have to be careful. So if you have any doubts that you'll get this derivative right, then I would say that you should just use your calculator straight up, and I'll show you how to do that. Okay, so this is x squared, it's a quotient, it's a product rule, times negative sine of x squared times the derivative of the inside 2x plus cosine x squared times 2x. Okay, and then I can type that in. So one choice I have is I graph from negative 2 to 2, and I graph f double prime. And then I make an f double prime number line. And this is the y value of the graph. Or I could graph the original, and I'm going to do both on the graphing calculator. So, or I graph f prime, which is the original, from negative 2 to 2. And then when I make my number line here, just from negative 2 to 2 though, so I don't really need the rest of the number line. This one also. So let me erase my number line. Usually when I have a number line that has regions, I'll just make a number line that looks like that. So let me do the same thing on this one. Okay. And I like to line it up right underneath if I can. So this is f prime. Now I need an f double prime number line, but this is labeled f prime. So that means I need the slope. So this is the slope of the f prime graph. Okay. So now I need to look at those two graphs. So I'm going to have to go to the other calculator. And then I'll come back and write the answers to those graphs here. Okay. So you should go on your graphing calculator, try to graph them, see how it works. It is cosine, so make sure you're in radians. Okay, so let's see on my phone. Did you try to type it into yours? Okay, on my phone I have these equations. Let's see. So I have, oops, we have x squared. That's funny, I just put x. Okay, I thought I put x. Okay, so, okay, this is annoying. So x squared times negative sine of x squared, close parentheses, times 2x. Okay, that looks good. Plus cosine x squared times 2x. Now this one I'm graphing the second derivative. Now while I'm here, I'm going to type the other one in too. So x squared cosine x squared. But really you would only choose one of these. I just want to show you how to do it both ways, just in case. What if it was something I didn't want to take the derivative of? And then we should get the same answer. So we'll see. That's how it goes. Now, I'm going to unhighlight the second one. So when I unhighlight the second one, which I did is I went on to the equal sign and then I hit enter and it made it so it's not bold anymore. What that does is it makes it so it's only graphing my y1 at the moment. Okay, I'm going to hit zoom. I'm going to hit zoom decimal. I like zoom decimal. Zoom decimal is like -4. Oh, this one's weird. Okay. Can you think of my error? I bet my error is that I'm not in the right mode. Oh, maybe I am okay. Oh, that looks cool. Okay. Okay, -2 to 2, it looks kind of exciting, so I feel like probably this is the right thing. But how would I check? I'd go to mode. Okay, I'm in radians. My graph is too wacky. So I'm thinking that I should only look from -2 to 2. I think I'll change it -3 to 3. Okay, so my x is -3. Oops, that's -36. So -3 to 3. Okay, I think the y values of the graphs looked pretty good. So let me hit graph again. Okay. Okay, so I'm going to take a picture of this to show you how I would make my number line. Okay, so I'll make my number line underneath, and then I'll transfer it to the other graph afterwards. Let's see if I can have a better color for this. I think green might show up. Let's see. No, green doesn't show up well. How about purple? Maybe I just need a thicker pen. Okay, never mind. We will use red, but I need to figure out how to erase. This is a new pen on my new tablet, so maybe I'll draw the number line somewhere else. Okay, let's draw the number line right here in the black. Oh, that's kind of cool. Okay, so where's -2? So -2 is right here. And then 2 is right here. Okay. So when we were doing this was graphing f double prime. And graphing f double prime means, okay, so from -2 to 2, I do above and below. So I'm below the graph for just a little tiny second. And then I'm above the graph until just past -1. And then I'm below the graph. So this is below. Okay, this is below. And then it looks like I'm above again. Let me change colors so you can see the aboves. So here's an above. Here's an above. Here's an above. And then I have one more below. We said what? That's red. So red. Okay, so I'm below, I'm above, I'm below again. And then there's 0. And then you're above. And then I'm below. And then I feel like I'm above again. Okay. Okay, so that would be the picture you'd want to draw if you were on free response. So you definitely would want to draw the picture that you're looking on your calculator. You know, multiple choice is different, but this year you're not going to have multiple choice. Okay, so that's kind of interesting. Let me save this. Let's see, I have way too many saves. That would be my pen save. I'm not sure. Maybe that's safe. Okay. Okay, let me go back in my other app. Sorry, I'm so slow. I believe that's this one. No, that's not that one. That's a camera. Okay. Let's see. That's because it looks like a camera. Okay, this one. Here we go. Okay. So this one, oh, that graph was so wacky. Let's see. Let me try to translate it on here. Okay. So the graph was below. It was below, and then it went above, and then it went below, and then it went through 0, and then it went above, and then it went below, and then it went above again. Okay, so that was the picture. Okay, so if I make green above, okay, so here's an above, here's an above, here's an above. And the reason I'm doing above and below is because the labels are the same. If the label of your number line is the same as your label of your graph, you do above and below. Okay, and then this is below, below, below. And I'm not looking at slope because I'm looking at an F double prime and F double prime, so then you do Y values. So that's below, this part's below, this part's below, and then these green parts are above. So above, above, above. And they want to know how many points of inflection. So this is concave down, concave up, concave down, concave up, concave down, concave up. So that would be 1, 2, 3, 4, 5 points of inflection. So the answer is 5. But let's look at what if that F single prime was very difficult to take the derivative of. Let's see if we could just graph F prime and see. And it's a little safer if you understand it. It's safer because you wouldn't have made a potential mistake in the derivative. So let's go back to that. Let's see. There we go. Close all. No, I don't want to close all. I want to go to this one. Okay, so we have y equals. Okay, I'm going to undo that one. I'm going to highlight this one instead. So go to your calculator. Pause if you need to. Okay, I'm going to hit graph again. Okay, now this is not the same graph because this is a graph of f prime. Okay, so let me take a picture of this one. Let me move this. Okay, so let me take a picture of this one so that I can write on it. Okay, so for this graph, and then, you know, probably I should change the window to -2 to 2. Oh, except I already took a picture. Okay, so let me change color so I'm not in red. Let me be purple. Okay, so -2 is right here, but probably that would have been a good idea. So -2 is here, 2's here. Now, when I do my number line, we'll put my number line right here. Okay, so when I do my number line from -2 to 2, we're writing f double prime, but this graph is f prime. So it's like a graph given problem. F prime, f double prime. That means that you're finding the slope of f prime to get the f double prime graph. Okay, so the slope of the graph right here, it's very hard to see, but I feel like it's going down. And then it's going down again here. And then it's going down here, from here actually, from the top, right? Here. It's It's much easier to see where it hits the y-axis. And then it goes down no more. Okay, and then the ups, we'll make up blue. Okay, so it's increasing here up until the slope is 0. Then it's increasing here. F prime is increasing, which is actually F double prime. And then I feel like it goes up for just a little. Much easier to see on the other graph, I feel. Okay, so from here, that would be the going up, or the increasing would be positive slope. This would be positive slope. And then this would be positive slope right before 2. Okay, and then the decreasing would be the negative slopes. So that would be negative slope, and then that would be negative slope. Okay, and then, oh, negative right here, negative slope right there too. Okay, and then that's the picture that I would need to draw on the paper. Okay, so I probably would make a better window so that I only have to draw the part of the window. Okay, let me hit save. Let me go back to my other screen. Let's not hit camera this time. Okay, this is the icon. Here we go. Okay, so let me look at my picture on my phone. This is kind of good so that you guys can see it. So if I twisted it the wrong way. Okay, so this was coming down for just a little bit. Coming down. And then I was going up. Let me change colors for the up. Okay, so then I'm increasing. I'm increasing until here. Then I'm decreasing. Okay, decreasing until here. And then I'm increasing again. Okay, then, and I'm just looking at the graph on my phone. So you want to be looking at the graph on your graphing calculator. And then this is, oops, decreasing. And then it's increasing again. Okay, and that's F prime. Now I'm looking for slope because slope of the F prime graph is the F double prime graph. I'm looking for points of inflection, which is second derivative. Okay, so this is going to be, the green is going to be negative here, and then negative here, right near 0, negative here, and then it should be positive in the other locations, positive, positive with the red, positive here. And if you look at the number lines look the same. Okay, so the number lines would be the same, the values are the same. If you actually needed to know what those values were, the second derivative method, the blue and green method over here would be better, because then you could use zeros to find these spots. Okay, otherwise it would be difficult to find these, because there is a button, it's called maximum and minimum, but you're not really supposed to use it on the BC test. So I would say I would probably do the one that I starred. Okay, this one's probably too long. Well, let me just finish 81 because it's on the same page. Okay, so f and g are continuous functions. Okay, so the integral there is p. Now p could be negative or positive. We don't really know at this point. The integral from b to c is q. The integral from a to, okay, so to, oh, that's a g. Oh, this is a g, this is a g. That's a c, that's a b. Okay, so let's start with what they gave us. So this is the integral from a to c of f of x dx minus, this was last year, a to c g of x dx. Okay, so you learned this in AB. Okay, and then they're giving me some more information here. So I'm going to kind of organize this, especially like I said, if it was free response. Okay, I'm going to work those out, but I feel like this is going to make more sense. So I have A, B, no, C it says is in the middle. It doesn't really matter. It works out no matter which one's in the middle. So if they didn't tell you which one's in the middle, but the fact they did tell me which one's in the middle, then I'd rather do it like this. Okay, the integral from A to C plus the integral from C to B equals the integral from A to B. Now, if you're on free response for this question, you have to make sure that you write your notation. F of x dx, f of x dx. And you're preparing for college anyway, so if you take math in college, you definitely want to label things appropriately. Okay, then that same formula would work for g. Okay, so the integral from a to b is p. And the integral from b to c is q. And let's make sure their bounds are right. Okay, their bounds are fine. I always like to do it the forward way. I don't like to do it by subtraction. I can subtract later. So the integral from a to c of f of x is p minus q. I'm much more comfortable doing that than trying to set up a subtraction where maybe I put the bounds wrong. So I always go forward. I always use a plus, and I just always go the forward way. The two little pieces add up to be the big piece. Okay, so that would be this value right here, p minus q. Minus, let's put a bracket, and then we'll find out what that is. Okay, so this is going to be the same idea here with the g's. Okay, so I'm just going to change colors. Well, if I was doing a free response, I really would need to write this out. So let me write this out somewhere. Do I have any space below? I do. Okay, so I might label this 1, 2, 3, so they could follow my work. Okay, so 2 is I would do the integral from a to c of g of x dx plus the integral from c to b of g of x equals the integral from a to b of g of x dx. And I'm only writing this because, you know, this year we don't have multiple choice, so I want to make sure that you show your work properly. Okay, this one, a to b is r, and c to b in that order is s. And remember, if it was like b to c, then you just flip the order. You know, that would be negative s. You can flip the order and change the sign. Okay, so in this one, let me move this up. So this one, the integral from a to c g of x dx equals r minus s. So that goes up here, right? This goes here. So that's r minus s. So we get p minus q minus r plus s. Oh, wow, I got to be real careful here. Let's see. This one's a plus, so that's not right. Negative r, so that one's not right. Plus s minus r minus q p. Okay, here we go. Okay, so I'll stop here and then I'll make another video for the next ones. I want to see what's next, what's coming. Area enclosed by the curve and converging. Okay, cool. Okay, so I'm going to hit save. First, I'm going to hit save on my video, and then I will hit save on this PDF. So I'll be able to give you this PDF too on Google Classroom.